Okay, welcome to section 2.2, day 2. Today we're going to start with some lovely bell ringers. Let's see if we can remember all of our derivative rules from yesterday without looking. So the derivative of a constant, so that was number 1. That was the derivative of C. Dude, that's a really bad attempt to do parentheses there. So the derivative of a constant gives me 0. Okay, number 2, what about power rule? Derivative of d over d of x to the n is equal to n times x to the n minus 1. That third one, the constant multiple, we saw this yesterday. D over dx of c times f of x is equal to c times f prime of x. So if you notice the way I've been picking up some of those, if you haven't been paying attention to how I've been saying some of that stuff, d over dx is how I say the derivative, or I can say the derivative of. A shorthand way to say that is d dx or d over dx. When I'm talking about the derivative of a function, again, that's f prime. So just be aware of some of those wordings. So I talked about the constant multiple, so next we're going to do the sum and difference rule. So first, the sum was the derivative of f of x plus g of x was equal to f prime of x plus g prime of x. So I just go ahead and split them apart, find the derivative, and then add them together. The other part to that was the derivative of the subtraction, so f of x minus g of x, which is the same thing, f prime of x minus g prime of x. That fifth one was then sine and cosine. So the derivative of sine, not 6. Come on, there you go. The derivative of sine of x is cosine of x. The derivative of cosine of x is not sine. So again, trying to remember those as best we can, just making sure we're aware of what's going on. We are not having to look back at our notes every single time. Trying to practice, learning these as best as we can. So again, more practice. If I'm looking for the derivative of y equals a constant, that constant, again, is still the derivative of a constant, which is my nice lovely donut hole. Same idea on 57. When I'm looking at this next one, the derivative of x to the 7th is going to be bring that 7 down, subtract by 1, so 7x to the 6th. Same idea here, power rule, 3 times 2 gives me 6, 2 minus 1 gives me 1, so it's just 6x. I have a couple power rules together, so I have 4 times 5, which gives me 20, so 20x to the 4th, minus 3 times 2 gives me 6, 2 minus 1 gives me 1, so I have 20x to the 4th minus 6x. Again, a couple power rules in one. Bringing down that 2. 2 times 3 gives me 6. So I have 6x. There's that invisible 1. Multiply that through, I get minus 6. So same idea with this next one. The derivative of 2x is just going to give me 2. The derivative of sine is cosine. So I have 2 plus cosine of x. Bring down that 4 to multiply with my 3, so I have 12x to the third. The derivative of cosine is not sine, so therefore it's going to be 12x cubed minus sine. The derivative of x, or just 1x, is going to give me 1. The derivative of cosine is not sine, so I'm going to have negative sign here. Negative turns positive, so I have 1 plus sine of x. Okay, so sometimes we can look at problems that look a little bit tough for us to do, but we are more than capable of doing them. We just have to think or manipulate the problem a little bit in order to solve the equation like we can or we would like to. So what I'm going to do is I'm going to show you some problems. I'm going to show you 4 different problems here. That's why you have the original problem spot 4 times. I'm going to show you how to rewrite it, then how to find that derivative and simplify it. So that first example there is going to be y is equal to 5 over 2x cubed. Again, we all know how great some of my writing is, so I apologize. I'm going to try and write it as best I can. I think I'm going to make my line size a little bit smaller, so that way we can differentiate it better. So when I rewrite this, I'm going to try and pull out any constants that I can. So my constant here would be the fraction of 5 over 2. We also agree that having my x to the third in the denominator is saying x, the same thing as x to the negative third. So all I did was pull apart my problem in order to make it something I'm used to working with. So now I'm going to go ahead and find this derivative. So when I find the derivative, I'm going to bring that negative 3 through. So I have 5 over 2 times negative 3x to the negative 4th. My lovely little cat is literally making a mess of my apartment, so if you can hear that, I'm sorry. When I go to simplify, I'm going to multiply this negative 3 with the 5 because it's going to go whatever on top. So it's going to give me a negative 15. That 2 is going to stay on the bottom because I cannot easily simplify that. X to the negative 4th is going to go to the bottom. So I'm going to make it a nice, positive, happy answer. So when I'm working with something that looks a little hard, so for example that original problem, I try and pull it apart to something I know I can do and then multiply through. So we're going to try another example. Again, I like how I can write better with this. So we're going to have y is equal to 5 over 2x all to the third on the bottom. And I can't remember my 3's today. Let me try that one more time, guys. I'm going to make it so that you can look back and you know that that is for sure a 3. Much better. Okay, so we know when we have something all to that power, we need to distribute that through. So if I distribute it through to my 2, I'm going to have 2 cubed, which gives me 8. So I'm going to have 5 over 8. Distribute the 3 to the x to the negative third. Because again, that negative 3 is on the bottom, or that 3 is on the bottom. So therefore, in order to make it, to bring it up to the top, I have to bring it and make it negative. So 5 over 8 times negative 3x to the negative 4th. So same idea as the example above. Negative 3 times, negative 3 times 5 gives me negative 15. 8 stays on bottom. X to the 4th. My next example is y is equal to, oh, I forgot to switch it, sorry. Y is equal to 7 over 3x to the negative second. So I'm going to pull apart that 7 over 3. X to the negative second, when I bring that up, is just x squared. All I have to do is, when I have a negative number, negative exponent on the bottom, it's like negative negative, it's a double negative. So I bring it up to the top because negative negative turns positive. So I have 7 over 3 times 2x. 7 times 2 gives me 14, so 14x all over 3. And my last one. Gosh, darn it. I have y is equal to 7 over 3x to the negative second in parentheses. So let's distribute that through in our heads. We know that everything's going to get that negative 2. Eventually that negative 2 is going to come up. 3 squared is 9. I'm going to take 9 times 7 and get 63 times x squared. So I have 63 times 2x when I take the derivative, which is going to give me 126x. So it is possible to take a problem that looks harder and make it simple. All you have to do is pull apart the, make sure you pull apart the constants, pull those out, and then go ahead and find your derivative over your x's then. Alright, that's all I have for you. See you tomorrow.